What the heck? It's time for dilution. Yeah, there's a formula for dilution. It looks like this. C1V1 is equal to C2V2. So you actually have to use a formula for dilution. Dilution is changing something concentrated into something that's not by adding extra solvent or water. C stands for concentration. Concentration, which is measured in moles per liter, and V stands for volume, which is measured in whatever. But you have to make sure your volume units on both sides are the same like scale, right? Like if you've got milliliters on one side, they got to be milliliters on the other. Okay. So you could have moles per liter and milliliters. That just means you need moles per liter and milliliters on that side. How do you know when you need to do a dilution problem? The question will say you are diluting a solution. Okay, let's try this one. If I have 2.5 liters of a 0.350 mole liter solution and I dilute it to 5 liters, what is the new concentration? Okay, so dilution, here's the solution. We need our dilution formula. You can set up a little toolbox. The concentration of the first system, C1 is the start. You could even say this is the concentrated side. And this is the dilute side, right? Concentration, concentrated and dilute. Okay, so C1 is 0.350 mole liter. V1, it's at 2.50 liters. We don't know the new concentration. The volume of the second system is 5 liters. So when I set this up and rearrange, C1V1 is equal to C2V2. I'm solving for C2. I'm going to get rid of the stuff on the right-hand side, which is V2. Dividing both sides by V2, I get C1V1 over V2. So when I throw my numbers in there to solve this now, I get 0.350 moles a liter. And I'm going to times that by 2.50 liters over 5 liters, and I wind up with 1. Oh, no, I don't wind up with 1. That's not right. Okay, 0.35 times 2.5 divided by 5. I get 0.175 moles per liter. Now, those of you who have some good math sense probably saw that we were doubling the volume. So by doubling the volume, we actually have the concentration, right? Like if you have you've made some Good Host iced tea and you add double the amount of water, the sweetness of it goes down and it starts to taste kind of disgusting. Okay, so that's that one. All right, let's try another question. All right. You need to dilute 0.5 mole liter to 0.115 mole liter. If I had 0.8, what is the final solution? Okay, so this is a dilution problem. C1V1 is equal to C2V2. C1 is 0.5 mole liter. V1, how much did you have to begin with? 0.8 liters. C2 is our more dilute solution. That's how you know if you've done this right? Your C2, well, we'll do this. C1 should be a bigger number than C2 because your C1 is your concentrated amount, higher concentration. We don't know V2. So let's rearrange for V2. Keep V2 on by itself, divide both sides by C2. There we go. That's our rearranged formula. We throw our numbers in there. 0.5 mole liter times that by 0.8 liters, because that's our V1 divided by 0.115 milliliter. Okay, what do we get from this magic? 0.5 times 0.8 divided by 0.115. I get to 3 sig figs, 3.48 liters. And hey, if we check it out, V2, because it's a bigger amount, it should always be bigger than V1. So here's the question. How do you make this solution? Well, if we had to make this solution, this is our final volume. Our initial volume was 0.8 liters. When we subtract these, that should give us the amount of water we have to add to make the solution. Okay, which is 2.68 liters. So that's the amount of water you would add to make your final volume. Hopefully that kind of makes sense, right? Like if you have some Good Host iced tea and you've got to make enough for a party, but you're too cheap to add more of the stuff, you have to add water to it to get to the final amount. If you know the final amount's volume and you know your starting amount's volume, well, the volume that's in between is the amount that you had to add. And that is dilution.